All right, in this video here, we're going to be taking a look at just a little bit of grade 9 review. This is for our grade 10 course, and we're going to look at a couple different things dealing with powers and how we can relate them together and simplify powers. So the first thing that we're going to look at is what happens when we have two powers which are being multiplied together that have the same base. Okay, so in this case here, we have 5 to the power of 3 being multiplied to 5 to the power of 4. That's going to be our situation here. And when we do this, the rule of thread or the rule of thumb in this case here is that we can add our exponents together to come up with our answer. So a question like this here, we're going to add our two exponents together, 3 plus 4, and that's going to equal to 7. Now, this becomes our new exponent, and so our simplified power is going to be 5, same base, to the power of 7. Here is a second one. Now, if you want to quickly pause this video and just try to figure it out on your own, it shouldn't take you overly long. Okay, give it a shot. What happens with this one here? We have two bases which are the same. In this case, it's 2 is our base, and then we can add our exponents together. What are the two exponents? Well, it's 5 and, yeah, I hope you know it. I hope you hear it. It's 1. Yeah, so we have to add those two together. When there's no power, so when there's no exponent on top of a number, that means that it has an exponent of 1. So you need to make sure that you're multiplying or you're including that 1 in there, and we're going to get 2 to the power of 6. So this means that there's 6 2's being multiplied together. All right, when we have a variable, in this case here, x, we can do the same thing. Give this one a shot. What's going to be our new power? So with this one here, because we are multiplying them all together, because they all have the exact same base, we can add all the exponents together. And so we're going to have 3 plus 7 plus 2 is going to give us 12. And therefore, the next exponent, or the new exponent on this one here, would be x to the power of 12. There are 12 x's being multiplied together. Okay, now, here is a question that deals with multiplying monomials together, or multiplying terms together. When you're doing something like this, you have to remember that you need to put together all the kind of pieces that are similar and multiply them together. The coefficients that are in here, so something like 2 and 3, are just multiplied together. 2 times 3 is 6. And so that's going to form there. Now, our x's get put together as well. We have x cubed times x, which when we combine them together is 3 and 1 together, which becomes x to the power of 4. And then the same thing with the y's. We have 1y and 2y's, and that becomes y to the power of 3. So in this case here, when we multiply it together, we get our new coefficient, which is 6. We combine all of our variables together, and so we have 4 x's and 3 y's, and we can write this into a simplified term. Now let's try some dividing. Does anybody remember the rule for dividing powers that have the same base? Well, when we divide powers that have the same base, we are going to subtract the exponents. So in this case here, both of them have a base of 4. We can subtract the exponents, and so our new exponent is going to be 6. And so 4 to the power of 8 divided by 4 to the power of 2 gives us 4 to the power of 6. And so we need to just subtract our exponents in that case there. Here's another one, okay? It's a division statement because it's a fraction. 5 to the power of 7 over 7 to the power of, yeah, I heard you, it's 1. You betcha, okay? And so when we subtract those two, we're going to get 7 to the power of 4. And that becomes our simplified power. Let's try with variables. In this case here we have m. When we divide these two, what do we do to the exponents? Yeah, subtract them. Give it a shot. Try it. What's 7 minus 4? Yeah, it's 3. You got it. Okay, it's m to the power of 3. So this is a part of simplifying our powers. We can do the same thing with coefficients as well. And now we need to divide the coefficients and then simplify those variables in there as well. Simplify the powers. And just be aware that the exponent is on the singular variable. So in this case, the 3 is on the w, not on anything else. It's just on the w. It's in the top. So 12w cubed divided by 2w squared. 12 divided by 2 is 6. W cubed divided by w squared would just be w. All right, next rule, and this is our last one here. This is our third of our rules. We're looking at what happens when there is an exponent outside a set of brackets. Now, if there is a singular term inside the brackets, we can transfer that exponent, which is outside the brackets, into the brackets. And to do that, we need to multiply every one of our exponents by the exponent outside of the brackets. Here, 9 squared, we can multiply the 2 by 3, and we're going to get, let's see here, there we go, multiply them together, we get 6. So this is going to be 9 to the power of 6, because we're multiplying those two together. Now we're going to look at other examples later on where there's more than one of those. All right, try this one. What's our new power? All right, hope you got it here. So we multiply them together, right? So 3 times 4 would be 12. And so our new power is going to be x to the power of 12. Okay, all right, so let's keep this going here. Let's try another one. We have 10 to the power of 8 to the power of 2. Now, so this means we have 2 sets of 8. And 2 sets of 8 would be 16 tens. And so our new one is going to be 10 to the power of 16. Hope you're able to get that. I know we're going through pretty quick in this one here. All right, what happens if we have two different things here? All right, there's a couple different ways that we can do this. One gives us a little bit more of an accurate answer. One is going to just follow the rules that we went through very clearly. So this squared, which is outside the brackets, is going to be applied to everything inside the brackets because it's a singular term. So the 2 has to be applied to the 3 as well as the k. So when we're doing this here, 3 to the power of 2 is going to be 9, and k to the power of 2 is going to be k squared. Now, if you would want to write this 3 squared, k squared, that works as well. But most of us should be able to do 3 squared, and so we can just put it into 9, as it is a fairly straightforward value that we're plugging in there. All right, let's try this one. Where does the 3 get applied? Give it a shot. Try this one out. So the 3 is going to be applied to both pieces. That means the 3 gets applied to the 4 as well as to the 2. Okay, it applies to both of them. 4 to the power of 3 is going to be 64. W squared to the power of 3 is going to be w to the power of 6 because you have to multiply them. So 2 times 3 is 6. Now, again, if you would want to write this as 4 cubed, you gladly could. Okay, but 64 does work as well, and you can gladly use a calculator in order to solve that. All right, try this one. Can you simplify it? All right, which of the variables does the 4 get applied to? It's both. Yeah, good. You got it both. Okay, so we have the M4, N4, right? And so that 4 is being applied to both pieces. And it's important, again, that each one has its own exponent in there. Inside the brackets, each have exponent of 1. Once you apply that 4 in, they each have an exponent of 4. All right, let's try this one. Can we simplify it? All right, that 5 needs to be applied into both of those brackets, or sorry, both of the terms inside the brackets, or both the variables inside the brackets. It's a single term. So 2 times 5 is 10. 3 times 5 is 15. So we have 10 x's and 15 y's that are going to be a part of this term. All right, we have lots of stuff inside the brackets, which is all a single term again. Let's apply the 2 in. Okay, which piece gets the 2? Yeah, I hope you said every one of them because it does. It sure does. Okay, 5 to the power 2 is 25. And then we got to multiply. 6 times 2 is 12. 3 times 2 is 6. And 2 times what's behind the C? Yeah, it's a 1. So it becomes a 2. And so it should look something like this when you're going through and doing it. All right, if we have something that is in a fractional form like this, same thing applies. That 3 is going to go to both pieces. So it's going to apply to the exponent on the 12, which is, so 2 times 3. It's also going to apply to the exponent on the m. So we're going to 4 times 3. And so our simplified one is going to be 12 to the power of 6, m to the power of over m to the power of 12. And so we're going to have both pieces in there, and they both get the application of that 3. All right, same thing in here. Okay, apply it in there. Give it a shot. Try it. Yeah, did you get it? All right, hopefully. Okay, exponent on the x is a 1, so it's going to be 4 times 1, so x to the power of 4. And then the exponent on the y is 3, so 4 times 3 is going to be 12. And we keep it at that. We can't simplify it any farther than that at this point. All right, what happens if we have a whole bunch of letters in there? Yeah, there's 4 different letters. Well, that 2 just gets applied to them all. So apply the 2 all the way inside the brackets. We have 6 A's, 8 B's, 10 C's, and 2 D's. Okay, so we just have to apply it all in there. Okay, each piece gets that application in there. All right, now we look at this one here. We have what's called a 0 power. Oh boy, do you remember this from grade 9? Hope so. All right, what happens if we have any number to the power 0? We get an answer of 1. Yeah, there we go. Done. It's across the board. So let's try a couple more really quickly here. What's negative 5 to the power 0? Anything to the power 0 is 1. Good job. Yeah, positive 1 in this case here. So there are, again, anything to the power 0 is 1, positive 1. What happens if we have this? I know I just told you everything is 1, but this is 6 to the power 0, and that whole thing is negative, and so our answer has to be negative 1, so be careful for something like that. It's something that could trip you up, something we have to be aware of. Because the negative is outside the brackets, it's not applied to the base, it's applied to the entire power, making the entire power, or the value of the entire power, negative. Okay, next one here. We're going to move on to a little bit more stuff with polynomials, which is kind of a follow-up to some of the exponent laws that we just looked at. Let's collect like terms to simplify the polynomial. It means we've got to collect all of the values which are like and try to make them into into simplified terms. Now you'll notice in this case here we have a 2xy and a positive xy. We can collect those two. That means there's 3 of them. Okay, 2 and 1 is 3. We also have 3x squareds, and we have negative 7x squareds, which is going to be negative 4x squareds. The variables and that variable combination is not going to change. It's just the coefficient that is going to change. We need to combine them together into like terms. Here's another one. Okay, a little bit more to it. Okay, we have 3x squareds, 2x's, and we have a constant in there as well. Pause it for a minute. See how you do. All right, let's try it out here. We're going to collect our x's together. We got 7x and negative x. That means we have positive 6. Our x squareds, we have negative 5, 3, and negative 4, which is going to give us a total of negative 6. And then we also have just that positive 5 that is by itself. And so we have negative 6x squared plus 6x plus 5. And that's going to give us our simplified polynomial. Okay, collect like terms, simplified polynomial. This one's a bit different. We have subtraction. So we're going to take everything in the first one, okay, which is that way. Yeah, there you go. Okay, and then put them into the second one. Sorry, that's blocking it a little bit. I'm just going to make my face a little bit smaller here. There we go. This means you get to see a little bit less of me. Now, when we collect these ones together, okay, we have 2m cubed minus 4m cubed, which is going to be negative 2m cubed. When we have 4m squared minus 2m squared, we have 4 minus 2 is 2. And then we have negative 5m minus negative 8m, which means we're getting rid of negatives, we're going up, and so we're going to end up with positive 3m. So you should have something like this as your answer. What happens if we have 3 pieces? Now we're adding and subtracting. So we're going to take the, I'm just going to kind of bring this over here a little bit. We have this one here, right? So we have the x cubed. This is the only other x cubed. So 2 minus 1 is going to be 1. Negative 4 plus 6 is going to be positive 2. And positive 7 minus negative 6 is going to be positive 13. And so that's going to be our final answer there when we collect all those together. Here's the assignment, things to take a look at on page 7 and 8. It's just the next part of it. There's 38 questions. Please take a look through these questions. Try some of them out. Try one from each kind of section. Try a couple from each section. Do as many as you can to get, just again, a reminder of the different concepts in grade 9 math. All the best as you work on your assignment.